This lesson is going to be about equivalent ratios. And the question I want you to think about as you go through the lesson is, how can you find equivalent ratios? Let's start out about getting the idea. Remember, a ratio can be written in simplest form. For example, 8:6 or 8:6 can be written in simplest form as 4:3 or 4:3. The ratio 8:6 and 4:3 are equivalent ratios. Models can help you tell if two ratios are equivalent or not. In example 1, we're going to use models to determine if the ratios are equivalent. So let's look at the ratios 4:3 and 9:12. Your strategy is going to be to model each ratio and then try to separate 9:12 into groups of 3:4. I want you to pause the video and try it on your own first. You're going to use circles. You can have the circles shaded or unshaded, and it probably would be to your benefit to use two different colors, whether you just leave one unshaded and one shaded, to represent each part of the ratio. Go ahead and pause your video now and try it on your own. As you can see from my example, in the first step, we're going to model 3:4 using white dots and blue dots. So I use the white dots of 3 to represent the 3 in our ratio, and then I colored 4 blue to represent the 4 in our ratio. In step 2, we're going to model the 9:12 using white dots and blue dots. So as you can see, I drew 9 white dots and 12 blue dots. The next step, in step 3, we're going to try to separate the model for 9/12 into groups of 3 and 4. Circle the group of 3 white dots and 4 blue dots. As you can see, we were able to separate those into groups of 3 to 4. So the solution is that these ratios, 3:4 and 9:12, are equivalent. As with most math problems, there's other ways to get the same answer. So I'm going to show you multiple ways today, and the next way is going to be something called cross multiplication. We can tell whether two ratios or rates are equivalent using cross multiplication. Rates are just a form of a ratio, and we're going to learn a little more about those as we go through this lesson and lessons in the future. So a rate is a ratio that compares two quantities with different units of measure. To cross multiply, write the ratio as a fraction, then multiply the numerator of each ratio and the denominator with the denominator of the other ratio. The products are called the cross products of the ratios. If the cross products are equal, then the ratios are equivalent. So let's try example 2. There are 2 photocopy machines in an office. The first machine produces 5 copies in 8 seconds. The second machine produces 16 copies in 24 seconds. Are the 2 machines making copies at the same rate? The strategy that I want you to try is to express each rate as a fraction, then cross multiply to see if the rates are equivalent. Again, pause the video and try it on your own first, and then we will go into the explanation in just a few seconds. Okay, in example 2 explanation, the first step you're going to do is express each rate as a fraction. So for the 5 copies, it took 8 seconds. So I'm going to write my fraction as 5/8. And then for the 16 copies, it took 24 seconds. I'm going to write my fraction as 16/24. The second step is we're going to cross multiply to see if the rates are equivalent. So I'm going to put a question mark over the equal sign because I'm not sure if these rates are going to be equivalent. So what I'm going to do now is I'm going to multiply 5 times 24. And when I do that multiplication, I get 120. And then I'm going to multiply 8 times 16. And when I do that multiplication, I get 128. So when I solve this problem, I see that they are not equal. So in this case, the two machines are not making copies at the same rate. The sign that you would use for this particular cross multiplication would be an equal sign with a slash drawn through it, saying that it is not equal. And that sign looks something like this. You can also cross multiply to find a missing value in a ratio or rate. So we're going to look at that in example 3 to see what I mean. Remember that when we don't know a value, we can use a variable to help us find the missing number that we're looking for. So you're just going to place a variable into the equation. So let's take a look. For example 3, Emma is driving at a constant speed. She drives 4 miles in 5 minutes. If she continues to drive at the same speed, how many miles will she drive in 15 minutes? So your strategy is going to be to write two ratios to represent the situation. You're going to use cross multiply to find the missing term. So remember, you're going to have a variable in your one of your fractions that you're going to write before you cross multiply. So pause the video, try it on your own, and then we'll go into our explanation. So in example 3 explanation, let's look at step 1. The first thing that we're going to do is write two ratios to represent the situation. We knew that she was able to drive 4 miles in 5 minutes, so that ratio is going to be 4 over 5. And you want to find the number of miles she will drive in 15 minutes. So the second ratio, since we don't know the number of miles, we're going to use an x. So it's x over 15. Once we have our fractions written for our ratios, we're going to come down and we're going to cross multiply 4 times 15, which I show here. And remember that little asterisk sign is multiplication. And then we're going to multiply 5 times x. Once we get those answers, this is what it's going to look like. We have 60 is equal to 5 times x. So to find x, we're going to divide both sides by the number that's with the variable. So since 5x means multiplication, the inverse operation is going to be division. So we're going to divide 5 by 5 and 60 by 5. That's going to tell us the values of x. So you can see that happening here. I divided 60 by 5 and 5 by 5. So the only thing that I have left here is x. So I'm going to go ahead and bring my x down. 60 divided 5 by 5 is a basic multiplication fact. 5 times 12 equals 60. So our solution for our problem is Emma will drive 12 miles in 15 minutes. There's another way that we could solve to see if ratios are equivalent, and we can use a double number line. If you've been in my class, you know I really like a double number line. So let's look at how that could take place. If we were looking at the example that we just did about Emma and driving, we could actually draw this double number line. The first line is going to represent the distance. The second line is going to represent the time. Of course, we always start at 0, so we're going to go, we know that she could drive 4 miles in 5 minutes, so that's going to be my first two numbers that are on my number line. I'm going to go up by 4 at the top, and I'm going to go up by 5 at the bottom. As you can see, when we get to the third value, I have 12 over 15. So this was the missing value that we were looking for. So once we get here, we found our answer. The double number line above shows that 4 miles in 5 minutes is equivalent to 12 miles in 15 minutes. So as long as the speed rate stays the same, you have an equivalent ratio. In example 4, I want you to use the double number line to find an equivalent ratio. So you're going to read the problem, and in this time it's Bruce. Bruce is riding his bike at a constant speed. He rides 3 miles in 15 minutes. If he continues to ride at the same speed, how many miles will he ride in 60 minutes. So go ahead and draw a double number line. You should have distance and speed representing your miles and minutes. Pause the video, try it on your own. For example 4, we're going to write the ratio that is known. So we know that he could go 3 miles in 15 minutes. So I'm going to go ahead and draw that double number line, and I'm going to show those two values. I know that the time for the next ratio is 60 minutes. So I'm going to go ahead and try to get my minutes up to 60. Once I've done that, then I'm going to take my miles. So I'm going to go up 3 each time, 3, 6, 9, 12. So the solution for this particular problem is Bruce will ride 12 miles in 60 minutes. Another way that we could find equivalent ratios is to use tables to solve for equivalent ratios. So let's look at example 5. A baker made this table to show the number of cups of flour and the number of eggs he needs to make a carrot cake recipe. How many eggs does the baker need if he uses 6 cups of flour? So we already know that he uses 2 cups of flour for every 4 eggs. So if we're going to look for a pattern, so you're going to look for the rule that relates to what's going in, what's coming out. I want you to pause the video and try to find the rule and find out the missing number. So the first thing that you should look at is, what is the pattern? The first ratio is 2 cups of flour and 4 eggs. So it's 2 to 4. 2 cups of flour, 4 cups of eggs. Not cups, eggs. So we're going to go ahead and find out how we get from 2 to 4. So 2 times 2 equals 4. So the rule may be to multiply each X value by 2. You need to make sure that pattern stays consistent with the values you know. So go ahead and check those out. We see that 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So that's going to be our rule. So as you can see with our rule, we're going to write that y is equal to 2 times x, or y is equal to 2x. We're going to find the missing value in the table. If the baker uses 6 cups of flour, x is equal to 6. So y is equal to 2x. If I replace that x with 6, 2 times 6 is equal to 12. So the ratio is 6 cups of flour to 12 eggs. That particular ratio is not in simplest form, so we're going to go ahead and find the equivalent ratio that is in simplest form. We know that 6 is half of 12, so the correct answer for this particular problem would be for every 1 cup of flour, there's going to be 2 eggs. So if the baker uses 6 cups of flour, he needs 12 eggs. Remember, we've been using the coordinate plane, and you can also plot ordered pairs on a coordinate plane to find equivalent ratios. If the ratios of x and y are equivalent, the points will lie along the same straight line. So I'm going to show you some examples of that, but I want you to try one on your own first. So let's look at example 6. The table shows the cost of shipping a package for different package weights. Now you can already tell they've given you the values. What you're going to need to do is you're going to draw a coordinate plane, and it's only going to be in quadrant 1. Then you're going to use the graph to find more equivalent rates. So the first thing you're going to do is you're going to plot the ordered pairs on a coordinate grid. Go ahead and draw you one and graph the lines for the ordered pairs, and then find 2 or more ordered pairs on the line. I want you to pause the video and try it on your own. All right, so the first thing that you should have done was plot points for each ordered pair on the coordinate plane. So you can see that I did 1 and 3, 2 and 6, 4 and 12. Now remember, the x values go before the y values, so I've got those ordered pairs already complete. The next thing that you're going to do is you're going to plot 2 additional points that are equivalent. So as you can see, I added some points here, and then I drew a line. I drew a line that has an arrow at the top. That means that if our numbers stay equivalent, we're going to have a straight line that continues. Hope you enjoyed the lesson today. Go try some on your own, and see what you can come up with. Have a great day.